Hi. So today in this video, I will talk about managing a machine learning project. I will take an example from the CCAS industry to think through and frame out a machine learning application project, and then work through a series of steps to evaluate the opportunity and walk through the business understanding, explaining why I have picked up this project. I would also explain and talk about developing a validation plan for the solution and key ML system design decisions. uh, I would also talk about identifying potential issues that may affect the final model in the production. So let's start. So this is my PPT which I have created, like how to manage machine learning projects for the application. So starting with the problem opportunity in CCAS. So one of the compelling problem in CCAS industry is presenting a strong opportunity for reducing the ticket resolution time. So basically, in many contact centers, incoming customer support tickets, whether they are received through email or chat or voice, are manually triggered and assigned to NOC engineers, network operations center engineers. So this process includes initial problem screening, customer questionnaires, and troubleshooting actions. So these are the manual procedures which are often inefficient, resulting in delays and inconsistent customer experiences. So one of the problem opportunity which I found is like faster ticket resolution time using ML. So why this is an attractive ML opportunity? I discussed like designing a machine learning system to assist NOXOC engineers in CCAS industry is an attractive opportunity because it directly addresses several operational pain points. Now, machine learning can transform this process by automatically interpreting customer queries and responses, recommending the most relevant SOPs or knowledge base articles, and automating the first level of troubleshooting as well for the common incident management problems. Now, what can a supervised learning model do? So, a supervised model trained on past tickets, historical data, and closing ticket notes can learn to automate the interpretation of customer queries and responses. It also learns to recommend the most relevant standard operating procedures, and it intelligently tries tickets, dramatically reducing the manual efforts and total turnaround time. Now, this leads to a faster responses time, improved customer satisfaction, reduced operational overhead, and optimized use of engineering resources can be done. So, now coming to the problem definition, what business objective we have derived. So, business objective, what we have derived is reducing the turnaround time for the TAT, for the customer queries, and resolving customer support tickets in CCAS environment by assisting NOXOC engineers with intelligent recommendations and automations. So, my data mining goal would be building a machine learning system that can interpret customer queries and responses. It This system can also recommend the most relevant standard operating procedures and prioritize the classifying tickets based on urgency and context. Now, we will discuss like why ML is suitable solution here. So, manual ticket tries and SOP lookup are the time-consuming factors, and they are error-prone as well. So, a machine learning concept can learn from the historical data and engineers' behavior, and they can use these data to automate and optimize these tasks, improving the speed as well as consistency. So, what would be the business success criteria for this machine learning application project? So, it should reduce the average ticket resolution time by 30% within 6 months of time frame. It should also improve first response accuracy by 25% at least, and it must increase the engineer's productivity, tickets resolved per shift at least by 20%. So, this should be by business success criteria. Now, what would be the ML success metrics? So, ML success metrics can be segregated into two, that is, outcome matrix and output matrix. Now, for the outcome metrics, average resolution time per ticket and customer satisfaction score, that is CSAT score, and escalation rate reduction should be the output metrics. sorry, the outcome metrics. For the output metrics, we should be recommending SOP accuracy, I would say precision or recall. Then ticket classification accuracy should be there, and sentiment detection factor should be there as an output metrics. And this overall describes the ML success criteria. So based on this, what should be the relevant factors that would be deriving and that would be driving the potential relevant features. So basically, for this, we would need ticket metadata, that is timestamp, channel, like which channel the ticket was raised, what is the customer's ID or circuit ID, what is the textual content of the customer ticket, what is the customer query, what are the engineer response after getting the tickets. And on the top of that, we can also consider for the historical resolution data, that is which particular SOP is used for the ticket resolution, what is the resolution time overall, and what is the ticket category. Uh, and In addition to that, we can also consider the system alerts and logs, which is correlated with the ticket context. So, keeping these factors in mind, we have derived the concept and how this concept uses the machine learning. So, uh, as a solution concept, we have developed ML powered Knoxock Engineer Assist for CCAS industry. And this proposed solution is a machine learning powered assistant which integrates to CCAS platform to help Knoxock engineers resolving customer tickets faster and more accurately. The system uses natural language processing to interpret customer queries and responses and classification and recommendation models to suggest the most relevant standard operating procedures and resolution paths. It also learns from historical ticket data, engineer actions, and resolution outcomes to continuously improve its prediction. So, this is about the solution concept and how it is using the ML concept. Now we would select certain strategy which would validate the model whether we are going on the right track or not. So to validate and refine the solution, we will execute a series of iterative experiments across the following phases. So my first phase would start with baseline model development, which is training initial models using historical ticket data and evaluating performance using metrics like SOP recommendation accuracy, ticket classification precision, and resolution time prediction error. Second phase would be controlled pilot development. So, deploying the model in a limited environment, that is one team or maybe one region or one BU, I would say, and collecting feedback from engineers on recommendations, relevance, and usability, like how it is usable to them, and then measuring impact on resolution time and ticket handling efficiency. The third phase would be A B testing, that is, comparing performance between users assisted by the ML system and those having the manual processes. And then tracking the metrics such as average resolution time, first response accuracy, and ticket escalation rate. The fourth phase would be feedback loop integration. So we would be using real time data or real time ticket outcomes and engineer feedback to retrain and fine tune the model, and then introduce active learning to improve performance on edge cases. The fifth phase would be feature engineering and expansion. So that would revolve around experiment with the new features, that is sentiment analysis, log correlation, ticket urgency prediction, and then evaluating their impact on model performance and business KPIs. The last and final round would be full scale rollout, that is gradually expanding the deployment across teams and geographies and monitoring long term performance and drift and schedule regular training. So, moving forward, we would choose the system design, like what would be the ML system design to go ahead with and why I'm choosing that model. So I will be providing rationale behind it. So designing an ML powered Knoxock Engineer Assist for CCAS involves thoughtful decision, and to ensure the system is intelligent, scalable, and secure enough, we would be going through a several ML system design. So my first design, which I would prefer, is model selection through transformer based NLP models. And why I have taken this decision is We would use transformer based models like BERT or GPT variants for log analysis, alert summarization, and incident classification. So why I have made this choice? This is because NLP model can understand the contextual strategy, and they are transformers in excelling and understanding the complex logs, tickets, and alerts in natural language. The second reason is multitasking. They can handle classification, summarization, and anomaly detection with the fine tuning. And the third reason is scalability. That is, pre trained models can be adapted to various CCAS environments with minimal retraining. Now, the second ML system design, which I would prefer, is hybrid approach. That is, a structured plus unstructured data. That is for the feature engineering. So I would decide to combine structured features, that is timestamp, severity, source IP, with unstructured features like log messages, ticket descriptions. Now, why I have made this choice is the comprehensive insights. So structured data provides metadata, while unstructured data offers rich context. Second is the improved accuracy. So, hybrid features enhance model performance in detecting anomalies and correlating incidents. The third is the flexibility, which supports diverse data sources like SNMP traps, syslog, and customer support tickets. The third strategy which I would be following is the deployment strategy, that is edge plus cloud. So, hybrid strategy I would be following deploying lightweight models at the edge for real time alerting and use cloud based models for deeper analysis and learning. So, why I have made these choices? Because of the low latency, that is, edge deployments ensures quick responses for critical alerts and resource optimization. Cloud handles heavy computation like retraining and historical analysis. And the third and final reason is security and compliance. So, sensitive data can be processed locally while anonymized data is sent to the cloud. So that is why I have taken this decision. Now, once a model is deployed, I mean, like ML powered Noxoc engineer assist system is in production, then we can face a several type of model related issues. Now, what are the risk factors we can identify which can reduce potential threats? So the my first potential issues which I would identify is training serving a skew. The issue is the model performs well during training but poorly in production due to differences in data formats or pre-processing. So the potential sources could be inconsistent feature extraction pipelines between training and live environment. There could be real-time logs that may contain missing or noisy fields and that is not present in training data. And the third one is data transformation, that is normalization and tokenization, which is applied directly in productions. So how to mitigate these issues? To mitigate these issues, we can use shared code ways for pre-processing. We can validate input schema consistency with automated checks and monitor model outputs for unexpected distributions. The second potential issues could be latency. So high inference time can delay alerting or incident response. So what are the potential sources for that? So large transformer models like BERT are computationally intensive. A real-time system can have strict latency requirements, that is 100 ms, less than 100 ms, I would say, and network delays and hybrid edge cloud setups. So, how to mitigate these issues? Uh, to mitigate these issues, we can use distilled or quantized models for edge inference. We can cache in frequent predictions or use approximate models, or we can optimize model solving with tools like ONNX and TensorRT. The third potential issues could be data drift, and fourth could be concept drift. So data drift could be input data distribution changes over time and reducing model accuracy. So there could be potential sources like new logs format or alert types can be introduced by system updates. There could be changes in network behavior due to new services or configurations. There could be seasonal or camping driven traffic patterns. So, to mitigate these issues, we can implement drift detection using statistical tests like KL divergence, We can retrain models periodically with recent data, and we can use online learning or adaptive models where feasible. Concept drift, the underlying relationship between inputs and outputs changes. So, what are the potential sources for it? It can attack patterns evolved. Sock knock workflows or priority shift could be one of the reason, and changes in incident severity definition or escalation protocols can also be one of the regions of the concept drift. To mitigate these issues, we can monitor performance metrics over time, like precisions, recall, etc. We can incorporate feedback loops from engineers to update levels, and we can use ensemble models that adapt to changing concept.